Hello everyone, welcome to my your programming club. Today we will be solving another daily LeetCode problem, and the problem's name is longest square streak in an array. Okay, so you will be given a integer array nums, and a subsequent subsequence of nums is called a square streak if following condition satisfies. The first condition is that the length of the subsequence that you would be forming from the a given array should be at least 2. Okay, and the second condition is that after sorting the subsequence, each element except the first element is the square of the previous number. Okay, so it should be something like this. If let's say the subsequence is like 4 2 and then 8, okay, 16. Okay, so it after sorting the subsequence it would be 2 4 and 16. See, we will be leaving the first one. Okay, so 2 into 2 is 4 and 4 into 4 is 16, so it the following condition should be there. Okay, the current one is the square of the previous one. Okay, 16 is the square of 4. Okay, and the length of the subsequence should be at least 2. Okay, so these two conditions, if a subsequence satisfies, then it is called a square streak. Okay, and then you have to return the length of the longest square streak in the given nums array, and you would be returning -1 if there is no such square streak existing in the given input array nums. Okay, and a subsequence is the array that can be derived from another array by deleting some or no elements without changing the remaining elements. Okay, so for example the array is abcd. Okay, so you can delete either 0 or uh, none of them, uh, or some elements, basically either 0 or some elements from the given array, and the rest of the elements would be remaining same. Okay, so this is also a valid subsequence, and if let's say we do not want to delete any of them, then this one also is a valid subsequence. Okay, so a subsequence in array can be derived from another array by deleting some or no elements without changing the order of the remaining elements. The thing here to be noted is that you would not be changing the order of the remaining elements. But here that will not anyways matter, because it is mentioned that after sorting the subsequence. So anyways, you would be considering a kind of sorted order. Okay. So before thinking of an approach, let's have a quick look at the constraints also. So according to the constraints, the length of the given input array nums and the entries in it will be both of order 10 raised to power 5. Okay, and so let's quickly try to think of an approach. So what we can do here is, see, first of all, as mentioned that the entries can be up to 10 raised to power 5. Okay, uh so 2 to 10 raised to power 5 each entry in the nums array. So if this is the order and we are considering powers of 2, then log of base 2 10 raised to power 5 would be somewhere close to 16 or 17. Okay, or if you want, you can think it of like this, that 2 raised to power 10 is 1024. Okay, and basically what I am trying to say is, even if it is 2 raised to power 20, okay, it will be something like this. Okay, so it would be the whole length of the subsequence that you would be forming would be very much restricted by this particular number. It would not be more than 20. Okay, it would be definitely less than that. Okay, so what we came to know about from this particular observation is uh, that if we somehow consider, let's say, nums array, and we are traversing this from left to right direction, and we are trying to consider each number. as the starting point of, as the starting number of its square streak. Okay, I think this is what they called it, square streak. Yeah. Okay. uh, then what you can do is you can be going up till only 20 length only. Okay, so if you somehow come to know that every time you would be squaring a number, let's say the number is x. Okay, so you will keep squaring this number until when you will be stopping when you are no longer finding the squares of it in the given nums array. Okay, so and you would be increasing the length of the square streak that you are getting. Okay, so for each number you would be doing that. And for to checking that whether a particular number exists in the nums array or not, for that to have fast lookups you can use a set. Okay, so set will be giving you whether a particular number is existing in the nums array or not in order of one only. Okay, so that would be our approach. So for each number we would be considering it as the starting number of its square streak, and we would keep upon squaring this number, okay, as many as times as its squares are getting we are finding its squares basically in the nums array. And when we will no longer be getting its squares into the nums array, then we will be stopping the whole process and we will be seeing what is the size of the current square streak. Okay, and we will take one variable, let's call this max square streak. Okay, so we would be uh, you know updating this whenever we are processing a number. Okay, and then we would be returning this. Okay, and now we will be seeing this in the implementation. So let's take the implementation to the board. So this is the implementation. So what we would be doing here is, so see, this unique numbers is the set that I was talking about, that would be used for fast lookups. Okay, to check whether a number is present in the nums array or not. Then what we would be doing is we would be feeding all the entries in the nums array to this unique numbers set. Okay, so that it have the entries of the nums array. And then we would be initializing one variable, as I talked about, maximum square streak length. Okay, and it would be initially set to 0. Then you would be traversing your given nums array. Okay, from left to right direction, entry by entry. Okay, and for each of the entry you would be doing the following operation. Okay, the first thing is that you would be initializing a length of the current square streak, and since we are at least having one number with us, so it would be starting from 1. Okay, and then the current number would be uh, the current entry of the nums array. Okay, and then we would keep squaring this number until we no longer find this its square in the unique numbers has set. Okay, or basically there is no long the square of it is no longer available in the nums array. It means that, okay, so till when it is happening, we will keep increasing the current square streak length. Okay, and we will keep updating the current number. Okay, so once you have exited this particular loop, then you would be updating your maximum square streak length with the current square streak length. Okay, and when you will be done with traversing every element, basically traversing this nums array from left to right direction and processing every entry in it, then you would be having your maximum square streak length. And if it happens that it happens to be equal to 1, it means that you are not able to find a square streak of at least length 2. In that particular case you would be returning -1, okay, as required in the problem statement. Else you would be returning whatever the maximum square streak length you have uh, you know collected. Okay, and this would be the approach and the implementation. And as far as the time complexity is being concerned, See, we are here doing a linear traversal. If let's say the size of this nums array is n, okay, then the time complexity will be order of n into since the number entries in the nums array were of order 10 is to power 5, so we were bounded by basically a number, the maximum length of the streak that can there be, so it was less than 20 only, so we can consider it linear time complexity. Okay, so this would be order of n only. And as far as the specs complexity is being concerned, see, since we are storing our numbers into the unique numbers asset, so it would be, in worst case, it would be order of n. So both linear time and space complexity would be linear. Okay, and this is the approach and the complexity analysis. So if you are still having any kind of doubts or any queries in general, then you can ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSA skills. Keep solving more and more problems, and I'll be seeing you in the next video. Thank you for watching.